lesson on acid-base properties of salts. Sometimes when you take a salt, an anion and a cation, an ionic compound, and you put it in water, sometimes it will be acidic, sometimes it will be basic, sometimes it will be neutral, sometimes it will be about neutral. You can predict this on the nature of the parent acid and parent base. The textbook goes into more detail from more of a theoretical dealing with Ka and Kb. I get the same results and it's a little bit easier. You might have to do some calculations on some of the problems with trying to actually find out what the pH or the value will be. So, if you mix a salt or an ionic compound into water, it will dissolve and make an acid and a base. This is the opposite of a acid-base titration. If you mix a strong acid and a strong base, they cancel each other. This is essentially what it is. For every proton, there's going to be a hydroxide. They cancel each other out, so the pH is 7. That's an oversimplification. It has to deal with conjugate acids and conjugate bases, but ignoring the so it is a salt of a strong acid, strong base. Will cancel out each other, pH is 7. Ignoring the particulars, you can predict this pretty well. If you have NaCl, you can stick an H in front of the Cl, so the anion gets an H in front of it, HCl, which is a strong acid, and you stick an OH after the Na, NaOH, that's a strong base, so you get a strong acid, strong base, pH is going to be a 7. And they cancel out, that's all you got to do. If you have a salt of a strong acid, weak base, the pH is going to be less than 7. For example, AlCl3, stick an H in front of the Cl, so it's HCl. Don't worry about subscripts, don't worry about balancing things. Plus AlOH. Al is not a group 2 ion or a group 1 ion, so it's going to be weak. So this is strong, this is weak. The strong beats the weak down, and the pH is going to be less than 7, so it's going to be an acidic solution. Because you got a stronger acid and a weaker base. If you have a salt of a weak acid and a strong base, the strong base overpowers the weak acid, and the pH is going to be greater than 7. Example, NaF, HF is not one of the 4 strong acids, and NaOH, that is a strong base, and so it's going to be a basic solution. This would be an acidic solution. Now, if you want to know what the pH is actually going to be, there's some math in there that you got to do. It's conjugate acid, conjugate base stuff. if you have a salt of a weak acid and a weak base. The pH is going to be around 7 in 5 to 9 range or so. It depends on how strong how weak the weak acid is and how weak the weak base is. If the weak base is stronger than the weak acid, then it's going to be more basic. So it's going to be around there, and it's tough to tell what it's going to be. AlF3, HF, which is already weak, he said, and AlOH, don't worry about balancing it. Al is not one of the first two comps, so that's weak. So it's going to be somewhere around 7. And to do the calculations on these, what you do is you have to figure out what, let's say that this, you're going to have to find Ka, and then you're going to have to find the Ka of the conjugate for that, and do the whichever one's the bigger number is the Ka you use to calculate the pH and stuff. You don't have to worry about that. I might come back and add on to it later, but for right now, this is all you got to do. That ends this lesson on acid-base properties of salts.